Welcome to June 4th's LeetCode challenge. Open the lock. You have a lock in front of you with 4 circular wheels. Each wheel has 10 slots. Strings of 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. The wheels can rotate freely and wrap around. For example, we could turn 9 to be 0 or 0 to be 9. Each move consists of a turn, 1 wheel, 1 slot. The lock initially starts at string 0, 0, 0, 0, a string representing the state of the 4 wheels. You are given a list of dead ends, meaning the lock displays any of these codes. The lock will stop turning and you will unable to open it. Given a target representing the values of the wheel that will unlock the lock, return the minimum total number of turns required to open the lock, or -1 if impossible. So think of this as just a regular, I guess one of those locker type locks in high school you get, where you could flip the numbers up and down and turn around, and you have 4 combinations, and then you want to flip it up and down, and the dead ends are the forbidden, I guess, places where you can't go. So you could kind of think of this almost as a kind of like a graph, a directed graph, where you start from the node 0, 0, 0, 0, and then you move 1 digit up or down at a time, and you want to find the shortest path in order for you to get to the target. So we have some examples here. So let's look at the hint. Actually, let's just not ignore the hint for now. So let's just kind of approach this problem using if we have a graph with a node and we want to find the shortest distance to our target, the best use would be a breadth first search type of approach. Yeah, and we're gonna move, and each time we move a combination up and down, we're gonna store our results so that we don't go back on our own path. So let's start off with the taking the dead ends, and let's make a set out of it because we want to, make a set. So dead ends equals set of dead ends. So we want to make a set out of that so that we have basically given an array in specific order. We want to make it so that it's unique and there's no replicating dead ends in there. So if string 0, 0, 0, let's just go through with the bare bones here and put down what we know. So if 0, 0, 0 is in dead ends, then return -1, because if 0, 0, 0 is a forbidden number, we start off with 0, 0, it's impossible to do anything, so we can't do anything about that. Also, if string 0, 0, 0 is equal to our target, then we're done, right? So that means that return our distance or depth that we go will be 0, because we didn't need to do anything, because that's our answer, which is pretty nice. So next let's start with we're gonna make a set of things we know to be true, and then we're gonna make a set of things that we need to approach. So let's just make 2 variables here called start and end, and we're gonna make sets out of those. So the first set is gonna have 0, 0, 0, because that's where we're gonna start. And our other set is going to be our target, or where we're trying to go towards. There you go. Now we have 2 piles to put stuff in. And then, so every time we make a step, it's gonna, call it a step then, I guess. Step. So we can't have step of 0, because if we do have step of 0, that means our answer, the given target is already given, so we return 0. So that should be step 0. But we can't do that, so it'll be step minimum of 1. Alright, so let's start our approach for a breadth first search. So let's enter while start, right? While starting set is not empty, we are going to make a new set. Let's see, a new starting point. New start. And that's going to be a set. So for each item in start, if it's not empty, we are going to cycle through each element of each item. So for I in range of length of item, and then for each item and each element of each string of each item, we're gonna check for if that value, the single value, is how it can move, right? If I in so we note that the number can go up 1 or down 1, right? For instance, if you have a 9, it can either go to an 8 or go to a 0, right? So it can move up and down 1, and we're going to develop that right now. So so it's given as a string, so we want to make it an integer. So for integer of item at position I, we're going to be able to add 1 and take the modulus of that. And then, so this is going up 1, but also it can go down 1 as well. So it'll be 10 plus the integer of the item at I. Take the modulus of that as well. Oops. And, oh yeah, I forgot the -1 here. So it goes up 1 or down or up 9. I mean, combine this together with that, but let's just leave it there. It's a bit easier to read this way. So once we have each element, each position, and each item, and each set, oof, that's a mouthful to say. Now we're gonna check to see, recombine put our new item in, make a new item out of it. So it's gonna be concatenation of strings here for item. So let's see the numbers before it. So it'll be I plus the string representation of J plus our end item. So we're cycling through each combination. Now we're putting it back together. Plus, plus 1. So we're taking the slices and putting them all back together. Now we have a new number, a new combination, either going up or down. So now when that happens, now we're going to check a couple of conditions for it. So if new item is in, let's see, is in the end, right? If we reach our target, I guess, then return the step, how many steps it took. Otherwise, if new item is in dead ends, then we're gonna continue out and break from our loop. So what we're gonna do is continue. So then now we have our new combination. We're gonna decide to do with it. If it is in our target, then we return the number of steps it took to get there. If not, then we're gonna continue, and then we're gonna add some things to it as well. We're gonna do new start. So remember, this is our initial starting set. We're gonna add the new item to it, so we don't count it again, so we don't traverse backwards in our graph. And then we're also gonna add it to our dead ends because we don't want to go back to there. Alright, so let's check a couple of conditions here now that we have that. So we kind of break up our loop here, and I think we should go to this area for each item in our start. If the length of the new start is greater than the length of our n, then we want to reassign new start to equal. Oh, we also want to reassign n as well. So we want to reassign new start to equal to n, and then n reassigned to new start. Otherwise, we want start to be equal to new start. There you go. Now we have a good system set up for our breadth first search, and we also have to increment our step by 1 because that takes we're taking another step outwards. And then if all else fails, return -1. Oh, okay, what am I doing here? Alright, this is that's an int there +1, take the modulus. Don't need this. Alright, that seems to be working. Huzzah! Accepted. So let's go over time complexity. Would be the length of the lock. Yeah, the length of the lock the string length of this. Yeah, length of the item plus dead ends plus the number of digits to the power of the length of this. That's pretty big. And space complexity is number of digits we have to the power of the length of the lock plus our dead ends. So we naively just took out the base options here, the base case here, I should say. So if it's 0, is in dead end, return 0. If this is our target array, return 0 because we're done. And then we stick a first step of 1 because that's our minimum. Then we enter our while loop here where start is not 0. So there's something in our start. Then we make a new set here for each, and we iterate through each item in start, and for each item we iterate through each position in the item. So that's individual indexes here, and for each of those we're gonna make them we're either roll up or down, and then we recombine our string to make a new item. Then we check if the item is in our n, right? If the item is in our targets, if it is, return the steps it took. Otherwise, if the new item we made, the new combination we made is in our dead ends, we're going to continue and put that into the new item into our starting point again, so we don't go back to it, and we put it in our dead ends. So next time we go through it, we're going to continue as well if that doesn't work. So we do this check here to see if the length of the new start is greater than the length of the end. If that's true, we want to reassign everything and and then do this while loop over again. So we reassign start to new start. Then we take an increment step of 1. If everything else fails and we continue here, then we break out and return -1 because we can't. It's impossible to get to our target combination if we keep on running into dead ends. And that's it. Have a nice day.